Runway Visual Range Definition. Runway Visual Range, RVR, is the range over which a pilot of an aircraft on the centerline of the runway can see the runway surface markings or the lights delineating the runway or identifying its centerline, ECHO. Runway Visual Range Concept. Categories 2 and 3 operations require rapidly updated and reliable reports of the visibility conditions which a pilot may expect to encounter in the touchdown zone and along the runway. RVR measurements replace the use of reported visibility values, RVV, which is not appropriate for conditions encountered during the final approach and landing in low visibility, because the visibility observations are often several miles away from the touchdown zone of the runway. Runway Visual Range Measurements. For Category 2 and Category 3 operations, the RVR measurements are provided by a system of calibrated transmissometers and account for the effects of ambient background light and the intensity of runway lights. Transmissometer systems are strategically located to provide RVR measurements associated with three basic portions of a runway: the touchdown zone, the mid-runway portion, the rollout portion or stop end. For Category 2 operations, the touchdown zone measurement is required, and for Category 3 operations the touchdown zone and the mid-runway portion measurements are mandatory. But for Cat 3 operations with the lowest weather minima, the three measurements are normally required by FAA. For Cat 3 without decision height, JAR-OPS-1 requires only one RVR measuring point on the runway. Research using flight simulators and flight tests have shown that 1. Most pilots require visual contact to be established about 3 seconds above decision height, though it has been observed that this reduces to about 1 second when a fail operational automatic landing system is being used. 2. To establish lateral position and cross-track velocity, most pilots require to be able to see not less than a 3-light segment of the centerline of the approach lights, or runway centerline, or runway edge lights. 3. To maintain a lateral level, most pilots require to be able to see a lateral element of the ground pattern, that is an approach lighting crossbar, the landing threshold, or a barrette of the touchdown zone lighting. 4. To make an accurate adjustment to the flight path in the vertical plane, such as a flare, using purely visual cues, most pilots require to be able to see a point on the ground which has a low or zero rate of apparent movement relative to the aircraft. Additional information on pilot's eye position. The pilots must realize the importance of eye position during low visibility approaches and landing. A too low seat adjustment may greatly reduce the visual segment. When the eye reference position is lower than intended, the already short visual segment is further reduced by the cutoff angle of the glare shield or nose. Airbus aircraft are equipped with an eye position indicating device. The optimum eye position is obtained when the pilot sees the red indicator ball covering the white ball. Additional information on landing lights. Use of landing lights at night in low visibility can be detrimental to the acquisition of visual references. Reflected lights from water droplets or snow may actually reduce visibility. Landing lights would therefore not normally be used in Category 3 weather conditions. Due to the very low visibility associated with Cat 2, 3 operations, authorities strictly regulate all aspects of this type of operation, in order to maintain the general level of safety in air transportation. Basically, 4 elements are strictly regulated: the aircraft, the airfield, the operator, the flight crew. Aerodrome operating minima. The limits of usability of an aerodrome for either takeoff or landing, usually expressed in terms of visibility or runway visual range, decision altitude, decision height, or minimum descent altitude, height and cloud conditions. For all Cat 2, Cat 3 approaches, aerodrome operating minima are expressed as a minimum decision height and RVR. An operator must take account of the type, performance and handling characteristics of the aeroplane, the composition of the flight crew, their competence and experience, the dimensions and characteristics of the runway which may be selected for use, the adequacy and performance of the available visual and non-visual aids, the equipment available on the aeroplane for the purpose of navigation and/or control of the flight path, as appropriate, during the approach, the flare, the landing and the missed approach. The obstacles in the approach and missed approach areas and necessary clearance. The obstacle clearance altitude, height for the instrument approach procedures. The means to determine and report meteorological conditions. Determination of the DH for Category 2. An operator must ensure that the decision height for a Category 2 operation is not lower than the minimum decision height specified in the aircraft flight manual. The minimum decision height to which the precision approach aid can be used solely by reference to instruments. The obstacle clearance height for the category of airplane. The decision height to which the flight crew is authorized to operate. 100 feet, 30 meters. Determination of the DH for Category 3. An operator must ensure that the decision height for a Category 3 operation is not lower than the minimum decision height specified in the aircraft flight manual. The minimum decision height to which the precision approach aid can be used solely by reference to instruments. The decision height to which the flight crew is authorized to operate.